Note number one, matrices. We're starting off Unit 5 talking about some matrices. We're going to be adding and subtracting first. A matrix is just a rectangular arrangement of elements organized into rows and columns, like an Excel spreadsheet. They're written inside brackets. You have your rows and your columns, which is R and C. So it's defined by rows and by columns. So you have your rows and then your columns. This matrix has 2 rows and 3 columns, so its size is a 2 by 3 matrix. And each element in the matrix is just called an entry. The entry in the second row, first column, second row, first column, so row 2, first column is 4. So that's how you read the matrix and figure out what numbers are where. Now with matrices, we can simply add them. In order to add them, they have to have the same number of rows and the same number of columns. And then when we add them, we just add the entries from each row to each row, each column to the same row and same column. What we mean by that is this first one, we want to add these two matrices right here. So we have 4 is the first row, first column, and 1 is also the first row. So we do 4 plus 1, which gives us 5. And then you do the same thing. So 3 is in row 1, column 2. 5 is in row 1, column 2. So 3 plus 5 is 8. And so 1 is in row 2, column 1. 8 is in row 2, column 1. So 1 plus 8, and so on and so forth. So we would just add whatever is in the same row and same column with each other to get our matrices. And we do the same thing with subtracting, except when we subtract, it becomes -1 minus 7, or 2, 8. So 2 minus 8. So we're doing the same process, except instead of using the addition sign, we're just simply subtracting. -3 minus 9. Now if you look at this one, we can't add these because this has 3 columns, this only has 2, so it needs that third row, so we can't do that. It has to have the same number of rows, same number of columns. So now we have a couple examples here. So when we look at number 1, we're adding these matrices, so we want 7 plus -4, 7 plus -4, 3. We look at, now we have 1 plus 0, well 1 plus 0 is just simply 1. 3 plus 9, 3 plus 9 is 12. So what we did with them is we wrote all of them in the same spot. So 7 and -4 were in the first row, first column, so 3 is in the first row and first column. When we look at the next one, well, -2 and 6, they're in the second row and first column, or the first row and the second column. Well, -2 plus 6 is going to give us 4, so we have to put that in the first row and second column. And then we look at the next one, and we just continue to do the same thing. -1 and -1 gives us -2. And finally, we have -5 plus 2, which is simply -3. And that is how we add up our matrix. So we can look at number 2. And we start here. We have 4 and plus a -1. 4 plus -1 is 3. 2 plus 12, 14. -7 plus 3, -4. Now we go down here. 0 plus 8. 11 plus -10 is 1. And -2 plus 7, +5. And now when we go to subtract, we're going to do the same operations as we did when we added, except we're going to subtract. So we have 0 is in the first row, first column. Well, -11 is in the first row, first column. So we get 0 minus -11. Well, 0 minus -11, a negative minus a negative, 0. We combine them, and it's going to be 0 plus 11, because the negative gives us the positive. It's going to be positive 11. Now we look at 3, we look at -2. Well, 3 minus a negative, well, that's going to turn into plus. Well, 3 plus 2 is 5. We have -5 and 5. Well, -5 minus -5, -10. And then lastly, we have negative 2 minus negative 1. Well, negative negative gives us positive 1, so negative 2 plus 1, simply negative 1. And then we're going to do the same thing over here. Well, 7 minus a negative 6, negative negative, positive, 7 plus 6, 13. 2 minus 18, negative 16. 0 minus negative 2, negative negative is a positive. 0 plus 2 is 2. 1 minus 1, 0. Negative 3 minus 5, negative 8. 4 minus 0 is simply 4. And then when we get down to number 5, we can subtract again. So 1 minus 1 is 0. Negative 1 minus 0, negative 1. 12 minus a negative 3, well, negative negative is plus. 12 plus 3, 15. 9 minus negative 2, 9 plus 2 is 11. 5 minus negative 4, negative negative is a positive. 5 plus 4 is 9. Negative 5 minus 21, negative 26. When we look at 6, well, we're adding again, so it's 3 plus negative 14, negative 11. 2 plus 8 is 10. 1 plus negative 7, negative 6. And negative 2 plus negative 5, negative 7. And that's the basics of adding and subtracting our two matrix. But what we can also do is we can do scalar multiplication, and any matrix can be multiplied by a constant. This is our scalar multiplication. When we perform this, it's when a matrix, each entry is multiplied by the constant, and we get our new matrix. So this is 3 times negative 65. So 3 times negative 65, which gives us negative 195. And then we do 3 times negative 21, which is negative 63. So scalar multiplication is just like the distributive property, because we have to make sure we distribute this to everything. So we have to do 5 times negative 2, negative 10, 5 times 7, 5 times 0 is 0, and then 5 times negative 4 is negative 20. So when we look at number 2, once again, we got to make sure we distribute that negative 2 to everything. Well, negative 2 times 4, negative 8, negative 2 times negative 1, positive negative times a negative is a positive. Negative 2 times 7 is negative 14. Negative 2 times 13, negative 26. And then we do the last row. Negative 2 times 5 is negative 10. And negative 2 times negative 2 is positive 4. So that's how we get that matrix. Number 3, well, even if it's a decimal, we can still multiply everything by a decimal. Well, 0.6 times 12, 7.2. 0.6 times negative 0.7, well, it's going to be negative 0.42. 0.6 times 0.4, 0.24. And 0.6 times negative 9 is negative 5.4. When we look at number 4, we're just multiplying a decimal by a couple different decimals. We do everything the same. So we do negative 2.5 times 0.5, which gives us negative 1.25. Negative 2.5 times negative 10 is positive 25. Negative 2.5 times 0.1, negative 0.25. And negative 2.5 times 0 is just simply 0. We can even multiply, the constant can be a letter, it can be our variable. So this time we have the variable m. Well, we just do m times negative 2, negative 2m, m times a, which is am, m times 6, 6m, m times e, it's em, negative 4 times m, which is negative 4m, and I times m is im. So we do it the same exact way, we just happen to have bunch of variables. And then the last one, once again, we're multiplying by negative z. Well, negative z times 0 is 0. Negative z times negative y, yz. We get negative z times x, negative xz, and negative z times 13 is negative 13z. And that's multiplying by our scalar multiplication, multiplying by that constant. And then we can actually add, subtract, or multiply by that constant. So we can do it all together. So when we look at number 7, the first thing we're going to do is we're going to distribute this. So we're going to distribute that 2 to everything. So we do 2 times a negative 4, which is negative 8. 2 times 12, which is 24. 2 times a negative 1, which is negative 2. 2 times 22, 44. So now I have my new matrix. Now I'm adding my next one. So we do negative 8 plus 10, which is 2. Negative 2 plus negative 6 is negative 8. 24 plus negative 14 is 10. 44 plus negative 12 is 32. So we simply we're doing our distributive or scalar multiplication first, and then we either add or subtract them. Now number 8, we're going to be subtracting these, but we have to distribute this negative 5 into everything first. Well, negative 5 times negative 7, 35. Negative 5 times x, negative 5x. Negative 5 times y is negative 5y, and negative 5 times negative 1 is positive 5. Now we're subtracting the second matrix. So 35 minus 10 is 25. Negative 5x minus 2x, well, they both have x's, so that's going to be negative 7x. Negative 5y minus a negative 1y, well, negative is plus, so negative 5y plus 1y is negative 4y. And 5 minus 2 is 3. And then when we look at number 9, it has a couple different operations. Well, the first thing is we have to multiply. So we're going to multiply by this. 3. 3 times 0 is 0. 3 times negative 15 is negative 45. 3 times 6 is 18. And 3 times 12 is 36. So we have our first one. Now, this is the part where people make mistakes, because it says minus 2 times this. Well, I'm only going to multiply by the 2, because when I do that, I'm going to bring this negative down into the problem. So that's where the negative is going. So I'm bringing my negative down, and I'm distributing the 2. So 2 times 7 is 14. 2 times negative 1 is negative 2. 2 times 3 is 6. And 2 times 0 is 0. Now, if you distribute the negative and then bring it down, you're actually using it 2 times, which would really make a negative, and a negative would give you a positive. And then I can just bring this one down. Just like with this first one, I multiply by 3, and I'm bringing my plus sign down. Well, now we're just simply adding all these. So we're adding and then subtracting. Well, negative 2 plus 0 minus 14. Well, negative 2 plus 0 is negative 2 minus 14. Negative 16. So now we have 10 plus negative 45 minus negative 2. Well, 10 plus negative 45 is negative 35 minus a negative, well, that's plus. So negative 35 plus 2, negative 33. We have 1 plus 18 minus 6. Well, 1 plus 18 is 19. 19 minus 6 is 13. And then the last one, we have negative 2 plus 36 minus 0. Well, negative 2 plus 36 is 34. And 34 minus 0 is simply 34. And that's the end of our adding, subtracting, and scalar multiplication of our matrices.